Okay, Paul switched us on. I'd like to thank everybody for attending this afternoon's webinar. I've got four technical points I'd like to mention before we start with the introductory discussion. These are the biographies of the speakers have been sent to you via prior email to the event. If you do have any questions to ask the speakers, please feel free to type them in the question tab on your toolbar. We will look to get through as many questions as possible. Any questions that we do not have time to answer will be sent to the relevant speaker and answered offline. And finally, the recording of this webinar will be sent to you within the next few days. So that's the 4 points. We get on to the first speaker, which, contrary to his name, is actually born and bred in London, Michael Cambero from SPG Global, who will present on COVID-19's impact on integrated C2/PE chain in 2020, a tale of two halves. So over to you.
Good afternoon, everyone. I'm just going to do a quick sound check. I just want to make sure that everybody can hear me before I make my formal introduction.
Yep, we can hear you, Miguel, but we can't see your screen yet.
Okay, I'm going to see how I can do that. I don't see the prompt here, so I apologize.
That's all right, Miguel,
okay,
don't worry.
I'm going to try now. Can you see my screen?
Not yet, Miguel. I'll move it back to you. Bear with me 1 second. Is it coming up, Miguel, or would you like me to host the slides for you?
Would you mind? Sorry, because I'm struggling to share them. Thank you. So I'll just kick things off. I'll just make a quick introduction. Thank you for the opportunity to present to you. It's an honor for Platts to be part of this event, and certainly for our department that looks at olefins and that looks at polyolefins in particular. So my name is Miguel Cambero. I am the editor principally for ethylene derivatives, and I look at the integrated chain in particular with ethylene into polyethylene and also into glycols. But one of the principal products that we look at is obviously polyethylene. And this is the focus of my presentation today. And in particular, it's going to be mainly focused on this year. I think it's clear to say that this year has been a unique year. Just a couple of points. So I've been with Platts for 15 years. I've covered a variety of different products, creating content and benchmarks for the variety of different things that we do, which is namely aromatics, olefins, and polyolefins. I'm just gonna, can you please switch to slide 2? Please, thank you. So as I mentioned, it's been a unique year. I think there is no rule book for what has happened this year, and I think it's also fair to say that there will be no precedence for what we expect to see next year. There's certainly a lot of uncertainty, and I think that if we just touch upon a few things so far this year, I think it's fair to say that for the integrated chain and in polyethylene in particular, the lockdowns and the pandemic that we've seen has caused a lot of disruption and a lot of uncertainty, and I think new challenges for a variety of participants along the integrated supply chain. And I think that talking to a lot of polyethylene converters, they've had to adapt to new situations, and of course adapt to new situations as we go into the new year, because normally you would expect to see certain behaviors and parameters like the financial year end approaching and destocking and things like that. But I think a lot of the guys that I've spoken to so far are pretty much adapting to new circumstances, and I'll touch on a lot of these things further in my presentation. So a couple of key takeaways to point out. Firstly, what we saw at the beginning of the year was, as soon as the pandemic started and the first lockdown was put in place, we started to see a correction or a shift in upstream feedstock costs, namely naphtha, dropping to low levels, and that's on the back of crude oil dropping to historic lows. But what we saw was, because of the way we reacted in terms of the lockdowns, we saw, I think it's fair to say that polyethylene producers, in varying degrees, depending on what market they were involved in, were seeing in some cases strong demand for their product, and in other cases very weak demand for other segments and other applications. But what it gave producers and converters to a large extent was an ability for greater competitiveness. So I'll touch on this going forward. I think one other thing to say is end use has become important as demand shifts have been tested. So we talked about some applications, automotive and construction saw a clear decline at the beginning of the year, which we've been seeing as a large trend over some months and years. Packaging demand, particularly for food and pharmaceuticals and these kind of applications, have strengthened, of course, as we've boosted demand for because our behaviors, our changed behaviors, have boosted demand for those applications. Personal care was another one. I think anything related to DIY and home improvements saw a massive change, and I guess we can say that it's been a very uncertain year. So can we move to the next slide, please? So I want to start off talking about the upstream situation. So this graph is a graph of our NAFTA CIF Northwest Europe cargo assessment, which is in dollars per metric ton. And what this shows is clearly that we've had a massive dip at the beginning of the year, towards the end of the first quarter, and that was obviously driven by the imposition of the lockdowns and the widening pandemic. So it dropped to just above $100 per metric ton, which is a historic low, I think at the beginning of the second quarter. And what it did was it provided a basis for a fall in feedstock costs, petrochemical feedstock costs. And I think it's fair to say that there were, talking to a lot of market participants, because of what they'd seen in the previous year, I think that it sort of gave them a hope that they might be able to regain some sort of competitive advantage from the US producers. Let's not forget that the US had been eating into the European market, as we saw with the growth in ethylene derivative supply, particularly from the ethane-based new capacities that have been coming on stream. And obviously there are more to come, but I think it was kind of a hope that they could see, that they could try and regain some of that or reverse some of that. Another item that I think from this graph, even though we saw the large dip at the beginning of the second quarter, what we've seen since is that prices have actually recovered. Prices have recovered, and I think any competitive advantage that might have been gained was short-lived. I think it's fair to say that also that naphtha volatility is something that will remain as an issue for chemical producers, and I'll talk a little bit further down the line in the presentation. Can we move to the next slide? This graph here shows you, represents the data that we have for our cracker margin. So I'm going to go further down in the integrated chain. And this shows the cracker margin from the ethylene contract price perspective and also from the spot price perspective. And again, as I showed you in the previous graph where we saw the dip in upstream costs, this graph, what we can say is that the volatility that this implies further down the chain has certainly been a feature for this year. And it really started since, I think, the end of the third quarter in 2019, as soon as the Saudi Aramco attacks happened then. And certainly since then, we've been seeing a lot of volatility and a lot of impact on cracker margins. So a couple of things to note here is that we saw, because of naphtha falling drastically at the beginning of the second quarter, we saw a re-establishing of margins. So contract cracker margins hit, as soon as the naphtha price dropped, they hit sort of just below the €1,000 level, which represents a significant margin gain for ethylene producers. And so also we started to see, following on from that, a recovery in integrated margins. And again, I'll talk a bit more about this. This was largely due to the rise in demand for food packaging, for personal care applications, DIY, because we stayed at home more. There was more of a dependence on those kind of products as we largely cleaned our houses more and we cooked more, etc. So those are the key items to sort of mention. But as I sort of touched on in the previous slide, because naphtha is still very volatile and we've seen naphtha prices rise sort of in the second half of the year, those margins have started to dent again. Rising naphtha has impinged on the cost of petrochemical producers. And even though we have a dependency on polyethylene, some of those sectors weren't really working out for some of those converters. I mentioned automotive demand was a segment that was trending down, but also construction. So again, it's fine to say yes, food packaging was fine, but reliance on some segments clearly wasn't the answer. Can we move to the next slide, please? So this graph shows the respective ethylene prices for the three regions that we assess. So we have, at the bottom, we have the free delivered Mont Belvieu price, which is basically the key US benchmark. The dark blue line represents our key European, CIF Northwest European ethylene price, and then the grey line represents the key Asian ethylene benchmark, CFR Northeast Asia. And I think from this graph, we can clearly say that up until the start of the lockdown period, we were still a large importer of ethylene. And also we were oversupplied in Europe. But this is something that I guess, if you look at the whole integrated supply chain, you could argue that ethylene producers were pretty content with that because the margins were being delivered on the cracker side in terms of contracts. So contracts were a lot higher, even though demand was weak for certain segments like automotive and construction generally, although they became a lot worse post lockdown. But obviously we were seeing a lot of imports, particularly from the US and the ethane-based suppliers from there. And of course, we then also had the building of the export terminal, which was set to increase exports further until lockdown happened. But as soon as we started to see the pandemic take hold and lockdown starting at the end of May, we started to see a correction in those prices. And in effect, even though for a period we still were above all the other regions, we then came down quite drastically sort of from May onwards. And Europe started to look at trying to reassess or trying to tackle some of the oversupply that we still had. Let's not forget that, US, just to point out a couple of these points, US ethylene imports became diverted away from Europe to Asia. So that helped the European situation. Again, we talked about the competitive advantage regained, or the hope that that would be regained. Ethylene prices for sure fell, and wider margins happened. But also those wider margins happened because we started to consume more for food packaging and those applications that were supported by the lockdowns. But by no means was that the answer, because as soon as naphtha costs started to drive up again, the challenge of trying to export and trying to produce was key. So yes, we became more dependent on exports, but obviously it was tricky to see whether they would happen. But of course, that gave an avenue to the European producers. Over to the next slide, please. So aside from what we've seen before in terms of the costs and sort of how ethylene has performed, I think since the beginning of the year, you could argue that this year largely has been one about regaining margin for polyethylene production. For the previous years, we started to see that challenged by the cheaper US producers with their ethane-based production. And obviously there was, I guess you could argue that some of those producers had a strategy to try and boost exports and challenge those higher cost regions, in particular Europe. So we saw an increase in imports. And then from the beginning of the year, that actually calmed itself down. I think that was largely due to the fact that, and this is pre-lockdown, of course, that the US producers were no longer willing to be as competitive. They wanted to justify the enormous fixed costs that they put in place to build those capacities, and so prices started to climb up. So that kind of eased the pressure a little bit. And I think there was also a resolute decision by the European producers to increase prices and try and reestablish those margins. This is pre-lockdown. I think what happened with the lockdown is that added further support. It not only kept away the imports because of the chaotic the chaos that implied, but also I mentioned the increase in demand for those key applications like food packaging and personal care that helped support those margins. So at the beginning of the year, there was either no margin made or perhaps some margin made. And then we saw that peak towards the end of the graph there in April, when obviously we saw the huge decrease in naphtha costs and oil costs, and that allowed for the producers to make margin. I should add that what this graph actually represents, it represents the difference between the contract price, which is the industry contract price for ethylene, and the actual assessment for free delivered Germany. So it represents it as a differential. So it gives a picture of whether producers made a margin or not. Now, as I mentioned, we saw a demand boost for key applications, which helped support those margins. And that's irrespective of the plunge in demand for things like automotive and construction, which were probably affected by the lockdowns. But obviously, this also depended on a strategy by converters to build up emergency stocks. It depended on stockpiling by consumers as we adjusted to what it meant to be in lockdown. And also, there was an expectation that demand would continue to increase throughout this. But as we've seen since those peaks, demand has adjusted. We've become, as consumers, adjusted to that new reality, and we no longer need to stockpile. So there are new challenges that are coming up. Can we go to the next slide? So again, I showed you the previous graph showed a picture of low density polyethylene margins. This is the same representation, but for linear low density polyethylene. Again, it's a similar picture. You can see the peaks there towards the second quarter. Can we move to the next slide? And as margins were being delivered, and I think the economies were largely adjusting to those new realities. This graph shows the differential between the key contract price, LDPE, versus spot as a discount. So as you can see, I think it's clear to say that this is like a representation of rebates or you know, rebates that maybe converters can expect to make based on the data that we have available. So those differentials are showing, or have been showing, pretty much around the 20 to sort of 27% mark. I think it's interesting to note that we've started to see changes in the supply of not only ethylene, but also derivatives, in particular polyethylene. We've seen a lot of force majeures and production glitches, and I think this is a key element to control by the producers. Obviously, there's a lot of uncertainty, there's a lot of demand weakness. So I think that's one of the things that they can control, and certainly we're seeing that now. And that's starting to take a hold on spot prices. We're now starting to see spot prices climb because of the tightness, because of the uncertainty over supply, and because of the demand globally, and also the lack of supply coming out of the US post-Hurricane Laura. Over to the next slide. I talked about how the upstream was impacted in various guises. I now want to show you a measure of how that relates in terms of imports and exports. And I've got the two graphs here, linear low density polyethylene, and I've got low density polyethylene on the other side. And I think what's clear is that the lockdown, the first lockdown, pretty much brought an abrupt shift in how much product we import and export. Certainly low density polyethylene is not as affected by imports as, say, linear low density or high density polyethylene. But obviously, nonetheless, there is an impact there. But if I show you, we just refer to the Eurostat data on linear low density, we can clearly see that there's been a sharp change in the amount that we both export and import. And I think one of the recent items we can say is that because of the control over production and because of the limited or the trimming of output from various different production units globally, we're starting to see lower exports coming out of the US, lower exports going to places like Latin America, Turkey, and Africa. And this has given European producers an opportunity. We're starting to see sort of in Europe, I think, a push and pull effect between tightening supply, as I mentioned, and also weakening demand for a lot of different applications. And this has actually belatedly had an impact on pricing now as of November. I think European producers were very keen to increase prices at the beginning of October because of the tighter supply, and obviously because of the increased demand from export markets like Latin America and Asia as well. They weren't able to do that to European consumers, but because of the reality of the tightness, they've had to accept higher prices, even though demand is very weak and there's a lot of uncertainty as to where demand will be in the first quarter of the next year. So we could expect to see a continued decline in imports, certainly coming into Europe, but also greater demand for exports going out to places like Asia, Turkey, to some extent, but also maybe even Africa and certainly Latin America, if the US production is not re-established post-Hurricane Laura. Over to the next slide. So I want to talk a little bit more about the key sectors I think that I touched on. So I think it's fair to say food packaging, personal care, DIY. If you're a keen gardener, sort of gardening centres have probably had a big boom in recent months as we've started to do the things that we've been putting off pre-lockdown. And certainly the other thing is DIY. I think I don't know how many of you are have had time to do DIY or gardening or whatever, but I think the trend is clearly there for people and consumption of these products. And these add a lot of value to certainly the polyethylene and polyolefins side. And we've seen a lot of demand for these products. I think, and I'll show this in the graph that's coming after, and obviously those sectors you know, that have also not had the same sort of positive outcome have been things like automotive and construction. But I think it's interesting, we're starting to hear signs that both construction and automotive are starting to respond positive. It's certainly better than they did in the first quarter. And I think, I'm not really sure whether that's greater demand for the old technologies, the petrol and diesel, which were sort of the pariahs in recent years, or whether it's the newer technologies, electric cars and these kind of things. And that's certainly where the future in automotive is for that segment. So yes, we're seeing a change a shift in consumption patterns. It'll be interesting to see how that develops going forward. Over to the next slide. So again, I mentioned automotive, and you know, this just clearly shows how volatile this shows EU car registrations from the Association of European Manufacturers, and certainly you can see that month by month we've seen sort of changes you know, versus the previous year, and certainly I think across all the different months we're down, but perhaps we could start to see this change going forward depending on which sorts of cars are being demanded. And I think the trend is towards the cleaner technologies, the electric cars, hybrids, that kind of thing. And of course you would have noted that I think it was last week that the government announced that it was bringing forward its ban of petrol and diesel cars. So again, that could see an increase in demand for hybrids and electric cars going forward. So we could start to see this play out in terms of demand for polyethylene. I think it's clear to say that things, again, I restate that the winners will be those kind of newer technologies, those kind of segments that we've seen in recent months. You know, again, things like sports equipment is seeing a lot of demand. I think certain brands that manufacture certain types of indoor bikes and weights and that kind of thing will see a boost in demand. Those are going to be the real winners. Those are the winners that if they can adapt to those sorts of patterns, will gain going forward. Over to the next slide. And again, I want to touch on high density polyethylene. Again, that's another segment that will see positives, but not perhaps as much as, you know, those applications that demand food packaging and that kind of thing. And I think those are clear. Those are clearly low density polyethylene in large extent. That's the real winner according to our own data. That's the one that's really putting demand for polyethylene. It's also pulling in demand for other grades of polyethylene. This week I was talking to a number of people who were referring to the tightness in low density. That's largely driven by force majeures and supply outages. And they're also saying that there is a spillover effect into linear low density polyethylene, because they're saying that for food packaging applications, certain applications that use both, they're seeing an increased demand for, say, in the case of linear low density applications, if they use if they use a ratio, say 80% low density polyethylene and say 20% linear low density, then those ratios are changing to say 75% and 25%. And also the shortages are affecting the variety of different grades there as well. So HDPE as well is seeing increased demand, not only from its applications, but also from varying regions. Over to the next slide. So a couple of key things just to point out and just to sort of bring everything that I've mentioned before. I think the key thing that I'm noting from the market is that there is a lot of uncertainty, whereas maybe there was a degree of certainty at the start of lockdowns in terms of where the demand was, in this case, food packaging, personal care and things like that. I think what we're seeing now is a lot of uncertainty. I think the reality of not only the second lockdowns, which are starting to bite, the measures that are being put in place to tackle growing unemployment, all of these are starting to have an impact on the macroeconomy. And so because we're seeing weaker demand as growing unemployment starts to take its effect, people are starting to watch their pockets, we could see a potential for deflationary pressure. And this is something that's worrying a lot of converters, certainly. I think also that because of this uncertainty, we're starting to see a refocus on the key items of watching their cash positions and keep an eye on margins. And we've started to see that from producers who have reduced supply, they've trimmed output to keep a tight rein on production, and thus try and influence the wider margin debate. And we're starting to see that now. You know, if you look at spot prices, they've started to climb. And if you talk to converters, they're admitting that producers are trying to increase contract prices in December, a month that is typically very, very quiet, and it's a reduced selling month. So a couple of key things to point out here. Delayed turnarounds are happening, more unplanned outages as a result, trimmed production, and a refocus on export markets. Now we're starting to see Asian prices shoot up. This week, you know, according to our own prices, both not only low density polyethylene, but also linear low density polyethylene and high density polyethylene grades have jumped massively in Asia because supply there is very limited and there's a lack of supply coming out of the US. So that presents an opportunity for European producers to export as netbacks improve. So if demand is weak, which we're hearing it is, they will
Miguel, can I give you a 1 minute warning, please?
No problem. Thank you very much. So that gives them an opportunity to export. So converters are very keen on hand-to-mouth buying. Can I move over to the next slide, please? So in conclusion, very quickly, a couple of things. Cracker economics will be challenging and will remain so. Again, reduced supply is coming into play and a focus on margins. This is not only from the producers, but also from the converters, and as they keep a tight rein on stocks and hand-to-mouth buying and just-in-time production. So these are going to be the key themes as we head into 2021 with all that uncertainty and all those macroeconomic pressures. Thank you very much. Any questions, please?
No, thank you very much, Miguel. I guess I have a very, very simple question. Do you think the North American shale gas situation will actually stop the European producers pushing the prices up too much?
I think there's a lack of supply coming out of the US for a variety of different reasons. We've had, obviously, the reduced production, and that stems really all the way from the top, from ethane.
Mm-hmm.
They're also seeing...
I need to cut you off rudely on this now because we're overrunning quite a lot.
No problem. So in answer, just very quickly, less supply will be coming out of the US, which is why the Europeans are trying to export as much as they can to make up for the shortfall in demand we're seeing and we're expected to see in Europe.
Great. Thank you very much for your time.
Thank you again.
You're welcome. I think that's very interesting to just look at what's happening from a macro level point of view going forward into the future, certainly for people who are looking at PE pricing into 2021. So moving on to I'd like to introduce Sean Mills from Rotational, who will present a case study on the impact of COVID-19. And very much appreciate this from Sean.
Yeah, good afternoon, everybody. I'm sat at home, so you'll have to excuse me if I'm a little bit rough with my voice, but I actually have COVID at the moment, so I'm keeping out the way of the office. Okay, so COVID-19. What has the impact been to us, the issues, and how will we tackle and implement them? We're looking at this for Rotatech, for myself and my fellow directors, of what we've had to input into the business time-wise, with people, training and paperwork, and the actual physical, emotional and mental impact that it's had on our business. So here we are, finding ourselves in this pandemic situation with COVID. As you know, the outbreak started in Wuhan, China, in December 2019. The WHO declared an outbreak on public health, emergency of international concern, 30th of January. Our government's own TV announcements on the 11th of March 2020 on the pandemic brings home some sort of reality and lots of confusion on what we should or shouldn't do. Do we close or do we stay open? So we have been quite lucky with the fact that we've got Gov.uk and many other outlets like the BPF, Make UK, to translate and generalise. We can keep our employees safe and secure in the knowledge that we're taking their health and safety seriously. Now, this has been one of the main drivers for us here. So we all set off and we do our risk assessments, but how do we know we've got them right? We realise as a business we need to translate this into specific actions. Depending on the nature of our business, including our group interactions and how it's going to be organised, operated and managed. So we've got the first steps. We knew this had a huge impact on our business in many areas. We needed to ensure that we keep the staff fully informed and, more importantly, engaged, as this has been by far the biggest struggle that we've had to deal with. You can take all the considerations by law, as I've put out below here. As an employer, we have the legal responsibility to protect the workers and others from risks of health and their safety. This means we need to think about other risks we face and do everything reasonably practical to minimise them. But you've got to recognise you cannot completely eliminate the risks of COVID-19. So we've complied an ongoing risk assessment and have committed to updating this and informing all the staff of any changes. I personally made a full effort to encourage any members of staff that may have any concerns to have individual discussions with their line managers or myself, including those who have any sort of uncertainties about precautions that we were taking in the workplace. I insisted that we all were involved with the decision making. Now this hits home that we wanted everyone involved to know that we were taking each and everyone's health and safety seriously. So when in the workplace, we had to ensure that we were taking every reasonable effort to comply with social distancing, ensuring that we were working to the guidelines set out by the government. So we found the easiest way to ensure each member of staff knew what 2 meters would look like was visual markers. So we painted the whole factory floors with crosses at 2 meter intervals in all directions. Now that stops me doing this, telling them, which has been one of the most challenging issues, keeping people apart and reinforcing policy. We put the normal posters up, do not enter if feeling unwell, or how to wash your hands and the frequency. Each and every doorway entrance has signage and hand sanitizer stations are all fitted. We temporarily stopped all the staff clocking in and out until we could add 2 new clocking machines to reduce the amount of people using each machine. We kept the numbers lower and the staff spread out at the end of each shift and allocated bubbles to use certain machines. I also took the decision to ensure that every member of staff, including all the directors, clock in and out for traceability and also showing full commitment to staff that we're all in this together. So we split all the teams up, staggered work and break times, which are coordinated by each team member to ensure that we do not overcrowd the factory, canteen. This limits the numbers that, because we've also removed some of the seating to ensure social distancing in rest areas. Most staff, however, seem quite happy to sit out in their cars during breaks, which has helped a lot. All benches and tables have antibacterial sprays for cell clean down, some separate bins for disposals of clean agents and waste. The use of toilets was an issue, so we also made arrangements for the factory staff to use the main office toilets, as well as keeping them as a one-in, one-out policy. Each toilet again has antibacterial sprays, hand sanitizing agents, wipes, separate bins, etc., and cleaning agents for waste. Smoking was stopped. Yes, it was stopped in the original smoking area, and we marked out the grounds with crosses for the staff to stand at 2 metre intervals until temporary smoking shelters could be fitted. This was so we kept all the social distancing maintained. These have now been installed with 2 metre markers. At all times, we kept encouraging and thanking the staff for their help on working with us on new policies in these areas. Of course, contract cleaner visits were doubled, and we appointed COVID ambassadors who are responsible to ensure that all cleaning is kept up to date and standards and regulated daily. Also, in the toilets, the mirrors are labelled with signs that say that you are the responsible for your own health and safety. So next is, how do we relay the information? Well, you're going to find that nobody's going to want to read a 20-page risk assessment. So giving this out to each member of staff is a waste of time. So as I mentioned, we set up in each area or team a COVID ambassador. Myself, all these guys and girls pull teams together and do signed off toolbox talks on any new or altering information that's been issued. They also ensure that all the teams' individual tools, work equipment, not shared equipment unless sanitised between each use, no shared oven gloves or work gloves, finishing benches are designated to each member. No staff overlapping during the shift. The COVID ambassador is also responsible for the end of each shift clean down, screens, keyboards and issuing of any PPE. They're also the liaison for staff that need information using WhatsApp if out of hours. So, what information do we need to give our staff and how? So we've taken a slightly different approach in how we pass information on and how and who they raise their concerns to. We found this easy to post on the website and send out as bulletins. Firstly, it gives the normal legal information, but we made it clear to all staff that they must know who they speak to, as we know that little or no information spreads misinformation to staff. We've told them all how it's going to be affecting them and how the working environment will be changing, how we thought working practices would change, and asked their input and implementing, especially reducing some tasks and machines to one-man working to ensure that concerns were resolved before starting. We asked them how social distancing would affect them and how they must adapt and control themselves, including travel, breaks and interactions between working bubbles and the two sites and staff in general. The normal information is always the start point for each talk as below. Increasing the frequency of hand washing, surface cleaning. All staff should be doing it as part of their daily routine. Keeping activity times involved as short as possible. Using the screens or barriers to separate people from each other, if this can be reasonably done to complete the task. Using back-to-back or side-to-side working rather than face-to-face whenever possible. Reducing the number of people each person has contact with by using fixed teams or partnering bubbles. So each person is only working with few others. And finally, if people must work face-to-face for sustained periods, more than a small group of fixed partners, then you need to assess whether the activity can go ahead and use the correct PP and face masks, etc. All meetings at the start or end of shifts had to be dealt with away from noise and at social distance to relay information from and to the incoming shifts. Signage all around the building, we put around about, I'd say about £12,000–13,000 worth of input on signs all over the building, outside the building, lorry drivers, everybody that's coming in and out has got full information on what there should be and what the procedures are. In the offices, the action taken, sneeze guards put up windows, reception window drop off and pick up points for documentation, screens built between desks for those not working at home, and walking screens for high traffic areas. Now, as you can imagine, we've tried to cover all the bases and have implemented all the documentation from the start. Company risk assessments updated weekly, staff work authorisation letters during the first lockdown, employee COVID basic training document, which each member of staff signs off to ensure we have a record of training for COVID on their records. We do workplace preparation checklists. We have a statement pandemic response plan. We have a working at our premises risk assessment, working from home risk assessment, visitors risk assessment, a visitors risk assessment questionnaire, company mitigation document, information on infected or with or has symptoms of coronavirus, information on infecting others with coronavirus, travelling to work safely. Then you come on to first aid measures if you're unable to maintain social distancing. All suppliers have been sent out questionnaires on how deliveries would be COVID secure. Annual leave questionnaires if travelling abroad or to a country not on the exemption list. How to self-isolate, including flowcharts. Returns to work policies for any work that's been self-isolating. Temperature testing was introduced, even though the government has now retracted this and said it's not a way of detecting coronavirus. We, however, have started it and continue to do so. All visitors on site have to follow all our rules or are not permitted to site, and if they are, they need to have filled in and returned a questionnaire before being invited. And we have a complete flow diagrams to simplify all or any of the information as on the next page here. This is one we put out for the staff on whether they need to isolate, just basically to give a rough guidance because of the amount of people that kept coming in with questions that my auntie's brother's dog's got it and so on and so forth. So, need to go back a couple. Yeah. Sorry about this. So, to summarise, we've tried to cover all the bases. We've completed COVID risk assessments and we'll keep updating. We ensure all our staff are kept fully in support using the COVID ambassadors, talks and monitoring. We ensure our staff are kept fully engaged in our efforts to ensure their safety. Any staff that are working from home or in self-isolation have at least one welfare consultation per week to see how they are and to inquire how their household is coping. HR keeps all staff updated on payments from the government schemes and SSP, but we've been fortunate enough not to furlough more than 2 staff up or have anyone off for any longer than an isolation period. So we're in this COVID pandemic situation that has little respect or consideration for our well-being and livelihoods, but we can only do what we feel right is for our employers and businesses. We have seen this impact has impacted on a downturn in 20% in some areas of our business, with inefficiencies brought into the production. On one site, we are still remaining to run machines with only 1 operator per machine. We're on the reverse in other areas of the business, we're up to 50 or 60% supplying the NHS supply chain, but we have the added pressure of trying to keep up with the demand. We have having to cope with the additional cost of management time this pandemic has added with all the supervision within the company, and I've insisted on the staff taking annual leave to help with this. We're having to carry the ongoing financial cost on sick pay, and we're still having an ongoing percentage of staff off for isolation. There is the cost impact on additional PPE, sanitizer, additional contract cleaning materials, the long-term cost on new equipment screens, laptops, home working equipment. There's the clocking machines, smoking shelters, and the range of signage. The cost of the additional HR and health and safety time and looking after the mental health and well-being of staff. And this is an ever-changing situation, and it's just one day at a time. The impact to some of our customers has been huge, and some are still closed for good. The impact and the added pressure with issues coming in on the supply chain, raw materials and parts from all directions now. But most importantly, the cost of trying to reduce the impact on our staff and families. We've put so much effort in looking after the staff with added treats weekly to boost the morale, as they have really gone the extra mile to look after the business. We do not know at this point what the full extent on the cost impact of the business is going to be, but it's certainly not small. But once this is over, we can try and assess it. But really, it's not that important as long as we come through this. Any lost ground can be recovered, but as long as we keep going is the most important factor for us, whatever the cost. Thank you. Any questions?
Thanks, Sean. There's a couple of questions that Paul's going to ask. I find that incredibly interesting, actually. It's clearly probably a lot more complicated for your business with a lot more people and less space than our business, but it was phenomenally interesting in my opinion. But over to Paul.
Well, yeah, thank you, Phil. So firstly, we've had a couple of people wishing you a fast and full recovery, and obviously let me mirror that. I think everyone on the call hopes that you make a fast and full recovery. Couple of interesting questions that have come in. Firstly, we've got a question coming in that there's been some anecdotal evidence that some staff have been difficult to reassure that the appropriate measures have been put in place and have sometimes reluctantly even returned to work. Have you experienced that at your business, and how did you manage that situation?
Yeah, certainly. We've certainly. I mean, I myself am the only person in the business that's contracted anything for some unknown reason. And we have had people, you know, I've worked with so and so, his mum's got COVID, so and so forth. But what we've done is said, all right, we'd follow the guideline and we put it out in the bulletins. And it's quite simple. Have they done this? Have they done that? Boom, boom, boom. And we just set it out as you've not had close contact, you've not done this, you've not done that. And it's basically talking to the individual and giving them as much information as you can, and also have it in front of them, because the worst thing is social media and their friends said this and their friends said that. So we've literally put it out on whether it would be a flow chart or impact charts that we have everywhere. So all around the building, every time a new document comes out, it's in the logbooks. The COVID ambassadors myself will go out and explain it all the time, and it's keeping them up to date with them and explaining time and time and time again. Because if you leave it for sort of 2 weeks, 3 weeks, it starts bringing in different things that they heard on social media or whatever else. But we find hit it head on. The whole point is to keep staff at work. So
absolutely,
straight away, people that are off nowadays with any mental issues, anything else like that, depression, things like, you're told to get them back to work as quickly as possible and do whatever you can to aid them. So that's what we do.
So just one more question that's come in. So quickly, Sean, has your supply chain been affected because of COVID?
Yes. So obviously we buy a lot of stuff in from China and places like that. That's had sort of a 2-3 month impact on stuff coming in from there. We've also found with raw material suppliers now that the impact is now coming on we can't get hold of this pigment, we can't get hold of that. So where you'd have a 4 to 6 week lead time, we've had some that have gone out to 12 weeks. And also trying to get the information out of suppliers has been a nightmare as well, because they can't give it because they haven't got it. So, you know, it's very difficult to plan your production when you never know when your materials are coming in.
Sean, thank you so much.
Pleasure.
Thanks, Sean. That was very interesting. We're now, I'm going to introduce Alex Pritchard from Queen's University Belfast, who will present on foam technology recent developments. Before he starts, I would say that following Alex's presentation, we've got a 15-minute tea break, which we're overrunning at the moment, so we'll probably bring that down to 7 minutes and catch up afterwards. So over to you, Alex. Thank you very much.
Hi, Phil. Thank you for the introduction. So can somebody just confirm that the screen share is definitely working on this before I get going?
Yeah, we can see you, and we can see a beautiful Queen's University slide now.
Thank you very much. So as already been said, my name is Alex. I'm a PhD researcher at the Queen's University of Belfast, and for the last 3 and a bit years, I've been looking at the optimization of foam structures in the rotational molding process. And what I'm going to cover today is a short overview of some of the technology that's been developed on the back of that project. So the first thing I'm going to do is give an introduction to the project itself, and then a bit of an overview of the rotational foam molding process for some of you that are perhaps not familiar with the process. Then I'm going to go into an analysis platform that I've developed to observe the foaming behavior specifically for the rotational molding process. Cover quickly some of the results that I've been able to capture using that method, and then talk briefly about some of the more futuristic technologies that have been developed on the back of all of this work. So just briefly, my project is part of a program called the Renewable Engine Program. It combines 4 different universities in Sligo, Northern Ireland. So we've got Southwest College and Queen's University of Belfast, and then the AFRC as part of the University of Strathclyde, based in Scotland, in Glasgow. So all of the projects in the program are working towards the advancement of manufacturing processes for renewable energy equipment, or specifically in the advancement of the renewable energy generation products themselves. So the aim of my research within this project is to investigate and optimize the processing of large-scale structures. There's an example on the right-hand side of what that structure might look like, which is a subsea tethered generation device. It's about 20 meters in diameter, so it's quite a large structure. And the hope is that we're able to manufacture that in a skin foam skin construction using rotational molding. So that has numerous benefits to it, being either the improvement in stiffness per unit weight that you would expect with using skin foam skin constructions, or in particular, the obvious aid in buoyancy by adding foam into the structure is quite beneficial to those devices. So to create a skin foam skin product, you've got 3 specific stages. You first create your polymer layer by charging the mold with a plastic powder, and then obviously heating with the biaxial rotation. To introduce the foam layer, then you combine a plastic powder with a thing called a chemical blowing agent, and that chemical blowing agent decomposes at a specific temperature, creating a gas inside the polymer, which creates the foam structure. And then you can then add a further skin layer on top of that before taking it to the normal cooling and demolding processes. So just quickly to highlight the current state of the art in the industry, the grey line shows a single layer molding, and the orange line then shows skin foam molding, a 2-layer molding. So at a certain point during the process, you're going to remove the mold and add in your foaming layer, the layer with the chemical blowing agent in it. You'll see a temperature reduction because it's now outside of the oven. And then upon charging the mold and replacing it back into the oven, there's a temperature increase. And you can pick up a slight gradient change in the internal air temperature. But one of the problems with this is it's very difficult to know how to optimize these foam structures based only on this information. So the purpose of the method that I've created then is to study in greater detail how to optimize these structures in a laboratory setting instead. And then there's a 20-minute increase associated with introducing the foam molding, which is a completely different topic altogether. So the aim of the study then was to understand how the foams develop in the low pressure environment of rotational molding. There's 3 previous study techniques that have been used in the research, being full-scale rotational molding equipment, and then more specialized smaller scale laboratory equipment, and then moving into microscope-based studies that are completely laboratory-based. So the first one, the rotational molding process itself, it requires significant amount of material, so that is a clear drawback to using it for research purposes. And in addition to that, then the closed mold makes it extremely challenging to capture data, which is why then you end up with the technology for internal air temperature still being the predominant method of monitoring these moldings. And then there's an example here of the smaller scale equipment, which obviously uses less material, but you still have the same challenges around capturing data. And then finally, the microscope-based studies, where you would have an offline heating rig on top of a microscope, which enables you then to be able to observe the foaming process at a microscopic level. That obviously uses less material, but it's also it doesn't create large molding, so you're not able to make things like mechanical tests after the fact, or perhaps more specifically, the amount of blowing agent has to be reduced in these studies to be able to prevent the overlap of bubbles obscuring the image altogether. So the objective and what I've been trying to achieve then is to develop a rapid and controllable method of capturing the behavior of these foams, and then use that method to study and understand the parameters that control how that foam grows in the process. The way I went about this was first by looking to other processes. So in the injection stretch blow molding process, they already used an oil heating method to be able to evenly distribute heat around the preform before it's blown into a bottle. So I've taken that technique and changed the preform for a glass tube, which enables me to be able to see the foaming behavior in real time. The obvious problem with that then is that the commercial oil baths that are available don't give you the side-on view that the glass oil bath in the third image there shows. And then finally, moving from that glass oil bath, you can then optimize and you end up with the final setup that I have. So the method itself enables capturing data quite easy because you're able to see the foam growth throughout the entire development process. And in addition, then the amount of blowing agent that is used is representative of those that are used in the full scale trial, which is incredibly beneficial for the optimization process then. So there's a quick diagram then showing the experimental method itself. So there's a heating side of the experiment, which is then completely replicated by a cooling side, giving me control of both heating rates and cooling rates in the experiment. So in the experiment, what I'm doing is I'm taking a rotational molding grade of medium density polyethylene. I've mixed that then with a 1% chemical blowing agent, in this case Chanatron OB. And this video here is going to show the full experiment as it is. So you'll see on the left hand side the test tubes entered into the oil. There's a short amount of time where you get the collapse of the polymer bed, and then after a certain length of time, let's just move that on a little bit, you'll see the foam starts to then develop, and at a certain point in the process you're then going to shift that over and watch how the foam shrinks on the other side. So I'm going to quickly share some of the results, although I don't have much time to be able to completely cover this particular set of results. So what I'm presenting here covers the effective heating rate, cooling rate, and the amount of time that you leave the foam sample in the oil. And everything else then in each experiment is kept at a mid-level. There we go. So in these graphs, they're perhaps more familiar to rotational molders. These are the change in melt temperature during the experiment, where you can pick up on useful information like the total amount of process time that's taken up by each sample and how that changes based on, for example, the heating rate, or how the gradient changes when you leave the sample in the oil for longer or shorter times, and then a comparison of the cooling rate showing the effect that you might expect using fan cooling in comparison to an external water spray cooling process. Perhaps more interestingly though, and the primary reason for creating this method was to be able to capture the data from these images and digitally analyze each one. So you'll see an example here where there's a red box that's drawn around each of the white polymer samples in the vessel. That red box increases with time, and all of this is done in real time using digital analysis so that it's able to export then the change in sample height against process time. And that then leads me on to the results that shows. So you'll see in the case of heating rate, by changing the heating rate, you can delay the onset of the foaming, but you can also shift the amount of foam height that's developed. In the case of the removal temperature, you can change the gradient, the rate at which the sample shrinks during the cooling process, as well as the maximum sample height of the foam that's developed. And then in the case of the cooling rate, you can change the amount of shrinkage and how quickly that shrinkage occurs just by playing around with the cooling rate. So as I mentioned earlier, the foam samples, one of the key things that you would usually do with a foam sample is take it to the characterization lab and you'd start looking at the cell structure under a microscope. There's a number of challenges involved in cross-sectioning these samples. So because you have a foam growing up the side of a glass wall, you get what I'm calling a wall effect, where the foam drags and elongates against the wall. So it's important to capture the information then at the center of the sample. And the foam itself is cross-sectioned in quite a specific way to be able to make sure that that happens in each image. But when you've cross-sectioned the sample, this is the sort of information that you can get from it. So in the case of heating rate, you can see that the higher oil temperature or the higher heating rate created a larger cell size than, sorry, I got that completely wrong. The lower oil temperature, therefore the lower heating rate, created a larger cell size in comparison to the higher heating rate in that first set of images, and then so on and so forth. You can compare the effects of one process setting against another. And then just to finish off on everything that I've been able to achieve with this method so far, I've actually started looking at how we can incorporate mold pressurization and use that to a positive effect on the sample height. So what I have here is a comparison of different levels of vacuum, which hopefully okay. So you'll see here that what we end up with is a change in sample height, with the sample height increasing with, come on. Okay, let's try this one. So you'll see a dramatic change in that final one, where the vacuum pressure is the highest. So there's a gradual increase in foam height with pressurization. And one of the key benefits to the process of doing that then is that you might be able to start reducing the amount of chemical blowing agent you need, which has obviously a cost benefit to it, but also an environmental benefit as well in doing that. So just to summarize that particular method, it's created a rapid tool for assessing the performance of foaming under rotational molding conditions. And perhaps for some of you, it's been the first time that you've been able to visibly see that foam height change under rotational molding conditions. The sample sizes using the method are scalable, so you could create foam structures as big as you need to create mechanical testing samples. The amount of blowing agent that's used in the experiment is representative of that is used in the rotational molding process itself. So that means the results could be directly related, although I haven't looked at that in detail yet. And then finally, the mold pressurization has shown clear benefits to using a vacuum in order to encourage that foam structure to develop in height, perhaps by then reducing the amount of blowing agent that's needed in the process. So I'm just going to quickly move on to some of the more futuristic developments that we've been working on here at Queen's. I'm going to cover a camera and vision system that we've been developing, and then some ultrasound sensors that have been applied to the process. And then quickly a discovery that I made in January of this year that could lead to blowing agentless foaming being possible in the rotational molding process. So in our lab, we have a electronically heated mold with heating elements all the way around the faces of the mold. It goes through the normal heating and cooling cycles with the fans in red underneath the robot there. That has been beneficial to my research because you can suddenly start putting sensors on the surface of this thing that you wouldn't usually be able to do in a gas-powered oven because you then restricted by having to protect the sensors from the oven environment. That then means that it's been possible to place a camera inside of the mold, which my colleague David has been working on. So there's two examples of that to look through. So at the start of the process, you'll see, let me scroll back a bit, the polymer passing past the camera as it lays up on the mold wall. And then at a certain point, all of the polymer powder is then laid up on the wall, as you might expect. And you can start to see transitions in the amount of bubbles that are appearing in the image, and also the surface roughness in the image as well. And you can just about pick up those bubbles in that video. And in David's case, he's looking at chopped fiber reinforced moldings. So you'll see that the fibers laying up in the melt during the process. I've then also been looking at using ultrasound as a tool for monitoring the amount of polymer that's laid up on the mold surface. So ultrasound has this ability to be able to pick up thickness, which is what this first graph shows, which is just a solid polymer sample increasing in thickness. And you'll see that the distance between the first and second reflection is increasing. And then if you compare that then with the colorful graph in the middle here, you can see there's a first and second reflection that's picked up sort of halfway through the molding, and then it disappears towards the end of the molding, which might then suggest demolding behavior around that sensor. So that has numerous benefits to the process. You might be able to pick up on and control the robot direction to be able to control thickness in certain regions using that technique. And then finally on to blowing agentless foaming. Rotational molding has this natural ability to be able to create air bubbles inside of the mold, inside of the polymer melt as it lays up on the mold. And if you pull a vacuum on those particular bubbles, then you can create a foam. So I'm just going to quickly skip through these a little bit. So you'll see at atmospheric pressure, the bubbles are pretty small. When you apply half a bar of vacuum pressure, the bubbles grow in size, and then so on and so forth to the point where you get to the full vacuum and the bubbles are pretty large in comparison to what they were originally. So you might be able to create foams in the future then by not having to use chemical blowing agents. And that could then be used in couple with the camera technology. And you could then create foams with controllable bubble sizes where the robot will automatically control the pressure line to be able to control those bubble sizes in the foam molding process. So thank you very much for your attention, and I'd be happy to take any questions.
Alex, that was very interesting. I think there's a couple of questions that Paul has. So it's over to Paul.
Okay.
Thank you, Phil. So there's two questions, but I think we can pretty happily combine them into one slightly larger question. So the question was, what class of agent have you used? Is it OBSH or AZO? And was the agent blended or compounded?
That is an interesting question. I know the Genetron blowing agent I was using was an exothermic. I believe, don't quote me on this, but I believe it was an OBSH blowing agent. It was turbo blended into the polymer using a laboratory scale mixer. Because the sample in that boiling tube is 5 grams, it wouldn't make sense to use an industrial scale machine, so a laboratory scale machine does just the job. And indeed, if you're trying to compare multiple different materials quickly, mixing 5 grams of material with a blowing agent isn't as much effort as it would be for creating 25 grams to run a couple of moldings on a full scale machine.
Okay, and thank you for that. The final question we've had, do you have any experience with recyclable plastic and foaming?
That is one of the things that we've been talking about for future projects. I haven't myself looked at it yet. Perhaps Paul, that is speaking later on, might be able to cover a little bit about that. I know he's been looking at using recycled materials for foaming.
Well, thank you very much. And Phil, that's the last question.
Great, thanks everybody. We've normally got a 15-minute tea break now. Can I suggest we reduce it to 10 minutes and come back at 58, start again at 58. Okay, ladies and gentlemen, I hope everyone's back now. I'd like to introduce Sarah. I'll leave it at that because we all know Sarah for a long time from Matrix Polymers now, who will present on biopolymers in the rotational molding industry. So it's over to you, Sarah.
Thank you very much, Phil, and thank you for mentioning that everybody knows me. It feels a little bit strange, I have to admit, being a presenter after having been an organizer for over 5 years. But here we go. So today I will be talking about biopolymers in the rotational molding industry.
Sarah, you're muted at the moment.
Oh, thank you, Paul. Have I been muted from the beginning?
You said you were introducing and then you moved to this slide.
Thank you very much. So it's clear that I very much want to impress the rotational molders after having worked for them for 5 years. What I was saying is that today I will be talking about biopolymers in the rotational molding industry. We will start by looking at the reasons why we are focusing on biopolymers now. Then we'll move into what biopolymers are, clarifying the definition and specifying the difference between biodegradable versus bio-based polymer, so a polymer based on renewable resources. And then we'll go into looking at renewable resources based polyethylene. So why are we focusing on biopolymers now? There are two main arguments. One is concerns about fossil resources depletion, and the other one is an environmental concern. As we all know far too well, I have to say, plastic has been in the spotlight in a negative way for a number of years. It has been indicated as the material that is responsible for the negative impact that our generation is having on the environment, especially on the aquatic system. There are many studies published, and the general public is well aware of them, mentioning that by 2050 there will be more plastic than fish in the ocean, that we are already eating some plastic when eating seafood and fish. But is the problem plastic? Is the problem the material, or is it more a behavioral issue? And what can we do to sort it out? Surely we need to invest in waste management infrastructures that allow converting post-consumer plastic into new product. Investing also in designing for recycling the product, thinking about it from the very beginning. But the main factor is educating people not to litter, teaching them about the value of plastic. And this is something that we can do as an industry. There are so many benefits that come with the material that we produce and sell. We can mention the one that probably has the most strongest emotional impact on people, the medical products. In medicine, plastic in medicine is improving people's life. Think about prosthetic, is saving life. Think about the heart valves. But also now, in this very difficult, stressful time that we are all living during the COVID-19 time, plastic is actually contributing, making our life easier. There are other aspects, of course, the positive effect of using plastic in the construction industry, where thanks to the insulating material, energy can be saved. Not to talk about the positive environmental impact of using plastic thanks to its lightweight, thus reducing carbon dioxide emissions. So a topic that is a sort of opposite to the argument that people use against plastic. But these are the reasons why people are calling for introducing new materials that they believe are more environmentally friendly. And now let's look into what these materials potentially are. So biopolymers. The definition of biopolymers itself, I think, a little bit misleading, because it makes reference to two concepts that are not the same. It refers to biopolymers as either biodegradable polymers or polymer based on renewable resources, so bio-based polymers. One concept is related to the functionality of the material, the other one on the resource from which it is produced. To understand the difference and why they are not the same, we need to look at the definition of each of them. So, biodegradable, what is it? We are all familiar with degradation, the loss of properties of a polymer. The definition of degradation doesn't specify what is causing the loss of properties. It can be thermal, mechanical, due to UV. It's not specified. While when it comes to biodegradation, the cause of the degradation is specified. It has to be microorganisms that initiate this action. Biodegradable materials are such material that can be converted to carbon dioxide, water, and biomass under the action of microorganisms. What are the factors that can affect the biodegradability of a product? There are external factors like the temperature, the humidity, presence or not of oxygen. We know that different microorganisms require a different environment to grow. But there are also internal factors related to the polymer itself, the molecular weight, the presence of branching, cross links, the presence of groups that are hydrophilic. They can all influence the biodegradability of the polymer. It's interesting to mention very quickly that the proposed mechanism of action for biodegradation of a polymer requires an hydrophilic external enzyme moving from the microorganism to the macromolecules to start breaking them down in smaller parts so that the degradation, the biodegradation can start. A concept that is often mentioned together with biodegradability is compostability, but the two things are not the same. A material can be biodegradable and not being compostable, while a material that is compostable has to be biodegradable. And this is the definition of a compostable material, so something that is biodegradable, that has a low level of heavy metal, no negative effect on final compost on compostability, and I left for one, the one that I mentioned a second, disintegrable, because this one requires further discussion. Disintegrable means that after exposing the material in composting condition, after 3 months of exposure, no more than 10% of the original massing weight is to be found. And that mass, that is the residual mass, cannot be bigger than 2 millimeters. So in shorter words, a compostable material is a biodegradable one that degrades quickly within 3 months without leaving visible traces and without releasing heavy metal or anything that can be toxic to the soil. Now, the other part of the definition of biopolymer, that was the biodegradable side. The other biopolymers are those that are produced from bio-based or renewable resources. The slide here, it's a very academic one, and it's just the definition of polymers according to their synthesization process. So we got those that are directly extracted from biomasses, those that are classically synthesized from bio-based resources. An example is the PLA, but we're going to talk extensively later on about the green, so-called green polyethylene, and those that are produced directly by microorganisms. As I said, I don't think that this slide is super useful. I decided to add it to make the description of what a bio-based polymer is more complete. I believe that this one is actually a more useful one because it should help understanding that a biopolymer that is a bio-based polymer is not necessarily a biodegradable one. So let's look at the bio-based polymers versus the fossil-based and biodegradable versus non-biodegradable. Some fossil-based polymers like PE, PP, PT are conventional plastic. They cannot biodegrade. Others that are still fossil-based can be biodegradable, like PCL, polycaprolactone. Then moving on to the bio-based plastics, Some bio-based plastic, like the polylactic acid, are not only based on renewable resources, they are also biodegradable, while others, like the bio-based polyethylene that you're going to be talking about, are not. And I think that this is an important useful definition, because very often when talking to people, there seems to be a general understanding that a biopolymer is a biodegradable one. That is not the case. And while that property could be a desirable one in some applications, for example, single-use cutlery, it cannot be useful in our sector. So who will want to buy a tank that they will need to replace after 1 year? Maybe it would be good for somebody to produce it, I don't know. And now moving on to the biopolymers that are currently used in the rotational molding industry. There aren't many that are used, with the obvious exception of the polyamide 11 that is obtained completely from castor oil. Going to talk about polyethylene, the most used polymer in our sector, I thought of presenting the differences in the polymerization process for the classically prepared one, the one extracted from oil or gas, and the so-called green one. So when the production of polyethylene starts from oil or gas, what happens is the cracking that converts the oil into ethylene, that is then polymerized using catalyst into polyethylene. For the green polyethylene, the bio-based one, the one based on renewable resources, the process, it's similar. So we start from sugarcane, wheat grain, they are then converted into ethylene and then converted into polyethylene. There is actually one step missing here, and is indicated in the next slide, in this one. What happened is that from the sugarcane, wheat grain, sugar beet, they are fermented to produce ethanol that is then dehydrated, so it loses one molecule of water to produce ethylene, that is then polymerized to produce polyethylene. As you can see, from the production of the ethylene on, the production method for the polyethylene is the same, and the properties of the gray polyethylene, so the classically synthesized one, and the green one, the bio-based one, are the same. It's interesting to note, though, how the carbon footprint isn't the same. So while for the classically synthesized polyethylene, there is an emission of 2.1 metric ton of carbon dioxide for each metric ton of polyethylene produced. For the green polyethylene, there is actually an absorption of carbon dioxide, minus 2.5. This graph indicates what happened during the growth of the base material that is used to extract ethanol. To this number, minus 2.5, we need to add 2.1, because this is what is then emitted into the atmosphere during the polymerization process. At the end of the process, the green polyethylene, it's almost carbon neutral. So what are the benefits that can be achieved by using green polyethylene or bio-based polymers? First of all, the direct use of renewable resources that become available again every year. In the specific case of the polyethylene, it can be recycled. During the growth of the biomass, CO2, it's absorbs during the natural process of the photosynthesis, thus reducing the carbon footprint of the molder. And then the green content level can be certified by independent laboratories, and it can help increasing the company profile in a moment in which the general public is the one that seem to be indicating that they want us to use this kind of materials. And now there are just some examples of what can be produced in the rotational molding industry using bio-based polyethylene. The examples, you will forgive me, are from some of our customers using our Renew XBK25 that has been on the market for a few years, 8 years. A special thank to JSC in Calendar Quarter for sharing this beautiful picture of the new product that they've launched. The general comment from rotational molders is that this material is easy to process and that it helps them both by reducing their environmental impact and also because it allows them to penetrate new markets. I'm very pleased to say that there are some news because our research on the sector of biopolymers carried on. And we are now about to launch, actually today is the first time that it gets mentioned, our new grade, the new 50GP, that's got an enhanced increased content of biopolymer and keeps a very, very good improved mechanical properties, while it's still easy to mold and it carries the same sustainability benefit. So in conclusion, what can we say? It looks like the general public is asking for biopolymers. Are they really aware of what they mean when they ask for the biopolymers? It's probably up to us to educate the public like we're already doing. It is, we say here, hard to predict the future. It is impossible to do it. We don't know what is going to happen. Surely, though, we know that PE is probably carry on being the dominant material in our industry, being it extracted from biomasses or classically produced. We don't know. Surely, using a bio-derived polyethylene can come with advantages, probably mainly related to the marketing opportunity that they will open for the molders that decide to use, as well as the environmental impact that we're going to have. And that's it. Thank you.
Thank you, Sarah. That was very interesting. I believe we have one question, so it's over to Paul.
Yes, thank you very much, Phil. So the question was regarding the minus 2.5 for CO2 emissions. Can you tell us what that is based on? Is that an average of maize and sugar beet impacts? And what would the CO2 number be if we quoted them for sugar, beet and maize individually?
That number, Paul, it's something that we've been provided by a supplier. And it refers to the sugar cane specifically. I think that those numbers are generally calculated, generic numbers, and I believe that the more indicative and useful piece of information will be calculated total carbon footprint for the rotational molders, and I believe that there are tools available that allow to calculate it fairly easily. I think that actually the BPF is going to launch a seminar in 1 week or something like that, after which we should all be able to calculate it on our own in 4 hours or something like that. It's just an indicative number and it's not an average to answer specifically your question. It's specific to the sugarcane.
Thank you, Sarah, and thank you for the plug as well. There is one other question that's come in. Is your range of biopolymers from 100% renewable sources? And if you do know, what are the processing temperatures in comparison to PE?
Our polymer is not 100% based on renewable resources. We got an enhanced percentage in our newer version. I think that if a molder is interested in finding out more about this one, I will be happy to take the question out of this webinar, if you don't mind, because it's otherwise disclosing a very sensitive information to potential competitors.
No, that's fine, Sarah.
But there is a substantial difference, Paul, in the quantity of bio content that is in our enhanced version. I can tell you that is double the previous one, while we have improved the mechanical properties, which is a very good thing.
Absolutely fine. Thank you so much. And there is a couple more questions. They're piling in now, but in the terms of time, we'll make sure that those questions are sent to you offline so that you get every question and get it answered. But that's all we have time for now. So for me, thank you so much.
Thank you, Paul. Please send them to, and I will be delighted to help. Thanks, and to answer.
Great, thanks, Sarah. So next we have Ryan Diggory from Bayes. who will present on Brexit, the UK government's perspective. Thanks for your patience, Ryan, and it's over to you.
Ryan, you're currently muted. Oh, there we go.
Thank you, yes. Do you have my presentation up, Paul?
That's not a problem. If you give me 2 seconds, I will get it up.
Thank you. Sorry, I'm having to use my personal phone, so I'm not allowed to use my laptop for this, sorry.
That's okay. We are delighted to have you, and your slides are now on the screen.
Thank you very much. Good afternoon, everyone. Thanks for having me. I'm going to try and go through slides quite quickly to give plenty of time for questions. So I'm aware you may have quite a few of those at the moment. For those of you I haven't spoken to before, my job is in the materials sector teams at the Department for Business. So my primary task is to represent the needs of the plastic sector alongside the chemical sector, steel, aluminium, and other materials manufacturers in the UK, in the UK's trade negotiation positions, and also in our domestic policy positions on international trade as well. Obviously, at the moment, quite a lot of what I'm doing is events like these, where I'm trying to help people navigate the very difficult and long list of things that are changing on the 1st of January and afterwards, and also I'm very happy to take your questions on a broad range of subjects as well. And I will do my best to answer those where I can, and if I have to take some away, I'll obviously put them back around via Paul in writing. Next slide, please, Paul. I will also say that you should have these slides to click through any links that are on them. They're not designed to provide death by PowerPoint, but rather just to have some very high-level reminders and some hopefully useful web links for you. I'm going to say something very quickly about UK-EU negotiations, a sort of long-running saga if ever there was one, and something I'm aware is probably the result, well, sorry, the cause of an awful lot of frustration in companies right now, where really you just want to know what's happening. Sadly, I can't tell you that at this point in time. I've just come off a call with some of the people supporting negotiating teams. They're still at it, going through all sorts of levels, at all levels of detail. And indeed, we're still negotiating quite hard on various things that will be of real importance to plastics exporters and importers as well, such as tricky things like rules of origin within a deal and how easy they are for companies to use so they can get rid of tariffs. And that is very much obviously the central thing about the free trade agreement, all the way through to can we secure things like mutual recognition of testing and conformity assessment as well between the two parties. So lots of things that are still under discussion, in addition to what you've seen in the news about fish and state aid rules and things like that. We've said it's going to be soon, again and again, at events like this. It is dragging on. I'm very happy to take further questions on it later, but I do think it's quite positive that people like me are being asked lots of questions still as negotiators try to find whatever compromises they can, and different things are weighed up. So it had a period of time, I think it's fair to say, around about September, and where things weren't moving, and I think they definitely have been moving over the last few weeks, and there's a lot of work going in to make sure that once those high-level political trade-offs are made, that the detail, some of which really will matter to people in the plastic sector, is worked out. It's also worth reflecting upon some other agreements that are very important. So it's not all about the EU, so I'm interested to hear from people who are dialed in today who have questions about other free trade agreement negotiations as well. So we're just concluding some more. So with Canada, for example, unlikely to be a massive market for you, but just in case, which I think is a very positive thing. There are some gaps though, it's fair to say, in from the 1st of January onwards compared to where we are right now. So things really are a struggle with Turkey, for example, at the moment, which is an important market as a source of inputs and also as an export market for a lot of manufacturers, where I always say it won't happen, but it looks pretty challenging to get something in place for the 1st of January. So happy to take questions on particular markets later, but if you want the official updates, you can use that link on screen. Next slide, please. So I just wanted to really give a very clear message today, and that's what's likely to be in a free trade agreement of the type the UK is negotiating with the EU, and what's going to change no matter what happens in negotiations. And I think compared to where we've been in terms of being in the single market and the customs union, there is, I think it's fair to say, an element of overestimation of what a free trade agreement is going to get you. So obviously, one of the key things about it is tariff-free trade, right? So you can continue importing PE from the EU tariff-free, right? That's one of the things that will be included in a sort of standard free trade agreement, although that's subject to goods proving that they're originating in one of the parties. I can take questions on that later. We're looking for lots of other things that would be really helpful to businesses. Even down to things like cooperation on road freight. So if road freight operators from each party can operate in the other one, that should make things cheaper than they would be in a non-negotiated outcome. Also in a non-negotiated outcome, right, so what you'd call no deal, and I'm not allowed to, you will face things like visa requirements for hands-on work in EU member states, for example. So yeah, we're still trying to negotiate a free trade agreement that will make supplying and receiving services easier as well, and things like transferring people within companies. On technical standards and national standards, we're trying to negotiate still a framework where we can retain some of the recognition of those. Again, this is something that's probably quite challenging for the EU, so it's by no means guaranteed, but I just wanted to give a flavour of the sorts of things we are trying to negotiate still. On the right-hand side of the screen, you've got what perhaps is a longer list of things, and really my main message today, still boring and frustrating as it might even be, is that most of the things we've been talking to businesses about over the last few months, in terms of things like customs processes, the need for declarations, there being a separation of the VAT areas, so import VAT applying between the parties, changes to product labelling, and the very fact there will be independent regulatory regimes, right? So regardless of free trade agreement negotiations, there's going to be a separation of regulatory regimes. There will be EU REACH and UK REACH. There will be CE marking and EU construction products regulation, for example, and there'll be UKCA marking in Great Britain and British product regulations. So it's really important to just bear in mind that a free trade agreement will get you a lot of things, but it will not change some of these fundamentals that we've been trying to go through with businesses. And I'm sure many of you have been trying to understand and work your way through over the past few months. Same goes here for, of course, Northern Ireland, and I'm happy to take questions on people who are trading with or through Northern Ireland as well. Next slide, please. You probably would have seen this already, so I'm not going to dwell upon it, but if you haven't looked at some of these areas of change on gov.uk so far, then please do so. Again, one of my jobs is to pester people in HMRC and DEFRA and all sorts of departments, my own included, to try to make guidance better, more practical, more accessible. So if you do have feedback, then I'm all ears. Let me have it. And yeah, one of my jobs is to to try to make things easier for businesses to understand as well, because there's an awful lot on the list that's changing at the moment. Next slide, please. There are some other resources as well, so you'll see it. The links are pretty self-explanatory there, but if you're interested in particular topics, for example, so I mentioned UKCA marking earlier, so if you, for example, were interested in that, you could go and sign up to watch a video over webinar like this on some of those specific subjects at the link at the top there. So there's lots of material on customs procedures, on chemicals regulations, on other product regulations, and so on, even through to things like intellectual property and transferring personal data. So there's a range of resources, that link at the top of the page. Obviously, it's a pretty long document. If you have seen it, it's an extremely long document, but the border operating model is something else I should flag. That really is the source of greater detail on how customs procedures in particular are going to work from the 1st of January onwards. So if you do have an interest there, then it is worth checking that out as well. Again, I mentioned Northern Ireland, so there's a link there at the bottom. There will be more detailed guidance on Northern Ireland coming out very, very soon from HMRC about the ins and outs of how goods will move, especially from Great Britain to Northern Ireland. So it is worth looking out for that as well. And if you are sending goods to Northern Ireland from Great Britain, if you haven't signed up to the Trader Support Service already, please do so. You can find that link through the one on screen as well. Next slide, please. So I'm not going to dwell on these because I don't want you to teach you to suck eggs, and I want to give plenty of time for questions. So feel free to go through this afterwards, but I thought I would quickly point out some of the key, what I think, it's not exhaustive, but what I think some of the priority actions would be for businesses in the plastic sector. Some of these are quite simple, and some of them are a fair bit trickier. And obviously there's a reminder there that as there's going to be a border, come what may, from the 1st of January, if you haven't nailed down what Incoterms you're using with EU suppliers or customers, now absolutely is the time to do so. And from there, some of these other actions flow. It's also important to note that if you haven't looked into how you can postpone VAT, that's something that might be really helpful for cash flow, and there's a link to the appropriate guidance there as well. Likewise, if you want to get a duty deferment account, then you can now do so without having a full customs comprehensive guarantee as well. So if you haven't seen that, that might be worth checking out as well. Next slide, please. I thought I'd highlight some of the goods regulation issues as well. So if you're importing chemicals, monomers, even substances, like a packaged lubricant or cleaning product or whatever, and you're doing so as the direct importer in volumes per substance of more than 1 tonne per year, you may well have new obligations under UK REACH. So it is very much worth checking out that guidance. Likewise, if you happen to be manufacturing, maybe for yourself or for clients, for CE marked goods, then of course, as I mentioned just before, you now have separate EU and UK goods regulations, and you may have new obligations there as well. I put some other slightly more sort of niche regulations on there, just in case you or your customers have an interest. There's some helpful links there. Next slide, please. It's not all about moving goods, so there are also changes to other things, moving people being one of them. As I said earlier, while there are a few things that we're looking to make easier than the kind of no-deal default within free trade agreement negotiations, By no means are they going to remove sort of some of the real basics here. So if you're looking to employ people from the EU after the 1st of January, you will have to become a licensed sponsor with the Home Office, for example. There may well be changes as well if you're providing or receiving services between the EU and the UK after the 1st of January as well. And it is worth checking any obligations you might have for business travel. In addition, the EU is making a decision on this, but it hasn't come to that decision yet. So at the moment, until the EU grants the UK what's called adequacy status, there are additional requirements as well for organisations who are moving personal data from the EU to the UK, right? Only in that direction, there's no problem. You can carry on moving personal data from the UK to the EU without taking any further action. And there's also a link there if you do have intellectual property and want to check if you need to take any action to protect it, you can do so by clicking through on that link. Next slide, please. Right. I've tried to sort of rattle through things fairly quickly. I know you've been running a bit behind on time. Hopefully, Paul, there's a few questions. If not, you'll have to make something up creatively.
Well, thank you very much. And yes, we have had a couple of questions come in. So one consistent theme in the questions is to do with the UK ports, which I know is something that you've been discussing with my colleagues at the BPF for quite a while, and is a concern not just for the rotational moulding industry, but for the wider industry. There are reports of that we're going to be expecting delays at the ports. That's obviously going to be causing trouble getting raw materials and goods, well, raw materials in and goods out. What is the government doing to try and prevent these issues, and what can you tell us about it?
Okay, yeah, good question. So there's kind of two issues here, really. So I'll take them in turn. So one issue you have is one that's already playing out. I'm told, particularly at places like Felixstowe, where you have a big problem with the global container freight market, which has been kind of exacerbated in the UK by things like, you know, storage of PPE, problems with, excuse me, problems with port IT systems for the road freight industry to use. And we have had all sorts of reports recently from BPF members, but every other type of importer you could think of about these issues with container freight in particular at the moment. So I was actually on a call yesterday between the Department for Transport and the port operators and the freight representative organisations where they were running through that issue. And I think it's fair to say there still are some problems with particular management of delivery slots at certain locations. But other than that, that overall problem and how it's impacting the UK, they're starting to get through the backlog a fair bit quicker now. So if you are impacted by that, that's what I'm told, but it'd be good to hear your views. So there is that sort of current issue where government is trying to convene different bits of the sector. And it seems to be things are now starting to work their way through the system a bit, but obviously many people have seen delays and increased costs in the meantime, and that is definitely not a good thing. I suspect you're also asking about for the 1st of January. So there's a few different things that government has tried to do to improve the flow of goods. Some of these are still being worked on, which is a problem in itself, I'm well aware. So I'll just take it in stages. So the simple and sort of high impact things that the government's looked to do is obviously with what we're doing on staged import controls from the EU. So we recognise that obviously one of the key drivers of delays would be people not being able to comply with paperwork requirements. And while the EU is not taking similar action, it means we can't do exactly the same thing for exports. for imports into the UK from the EU, you do have this period of time between January and July, where the majority of goods imports will be able to come into the UK from the EU without full customs declarations or the payment of duties at the point of transit. So we see that as something that will make a big improvement, if you like, to the situation and lower the chances of catastrophic delays, especially on the places like the short straits. On the flip side, obviously my colleagues at HMRC, they're not quite there yet, but they are working very hard with the road haulage industry and others as well to try to improve the IT systems. And many of you will have obviously seen the information about things like the Kent Access Pass. So the idea there is for the roll-on, roll-off port locations in particular, you'd have as much sort of pre-lodging of customs paperwork as possible, and therefore pre-checking as well, just to avoid the need for checks to be done at port, and therefore for people who are not compliant with documentary requirements getting in the way of people who are compliant. So there's been a lot of work going into those systems as well. Understandably, there's a lot of concern out there about how ready the IT is going to be, but there are an awful lot of resources being put into making that happen. So those are some of the main things. I think, sessions like this where we go through what the actions are, are another thing that helps, because I still do talk to a number of businesses who aren't quite there yet with preparing for some of the paperwork, and obviously the more people in that position, the larger the chance of delays.
Ryan, I've got one more question that's come in. It's going to put you on the spot a little bit, so apologies in advance, but can you confirm that a trade agreement from January 1st with North America has been agreed in principle? Are you able to give us any update?
Not North America as a whole. So if you're referring to Canada, then it's extremely close.
And with America?
And with the United States, to be frank, it's quite a way off. Mm-hmm. And obviously, I think also in the United States, it's something absolutely we're trying to do quickly, but also well. So we don't have similar deadlines there as we do with the EU. And also, you've just had a change of administration, right? So inevitably, right now, things have slowed down a bit in terms of the US, while you have the new administration that's going to come in. And by the way, as you can well imagine, the US is quite a forthright trading partner. So, they're not the sort of people who say that we know where we're going to land and so let's get on with it. They're actually, as is their right, making it hard for us, and making it a slightly longer process, if you like. So, yeah, we're absolutely still 100% committed to those negotiations with the US, but it's going to be a little while yet before those conclude.
Ryan, thank you so much for today. Sorry, Phil, apologies.
No, not at all. I thought it was a very interesting topic. I'm the one who pushed for to get a BEIS representative, which I think was superb. Thanks very much, Ryan. So quickly introducing Paul Hanna now, given the maximum amount of time from Queen's University Belfast, who will speak on the Rotacycle project. So over to you, Paul.
Thank you very much, Phil. I'm hoping everyone can hear me.
Yes, we can.
Great stuff. Thank you, Paul. Good afternoon, everyone. I hope you're keeping well. I work in the Polymer Processing Research Centre at Queen's University in Belfast. For those of you who are not familiar with us, I'd like to start with a few brief words about who we are and what we do. But then what I really want to talk about are two research projects focused on the use of post-consumer waste plastic. The Rotacycle project, which is now finished, and more briefly, the Accept project, which is still ongoing. And then if you have any questions, I'll try and answer them. Our research centre has a core staff of 8 engineers and researchers, of which I am one, and we are ably supported by 3 business and administrative staff. Our core activity is collaborative research and development, all the way from benchtop studies right up to industrial scale processing trials and material characterization. We also offer industrial training programs, consultancy, and technology transfer. Our equipment includes most of the major plastic processing techniques. So obviously, I'll talk a little bit more about our rotomolding capability, and we have a robomold machine. We have twin screw compounders and also a 2-roll mill and a platen press for smaller materials. We have an Arberg 50-ton injection molding machine, which we use to produce mechanical test specimens and trial and prototype new products. We have 3-layer blown film, 5-layer tube, sheet, and cast film. We have a Vitali injection stretch blow molding machine. And we also have a custom-built biaxial test rig, which we use, in fact, to look at and characterize both thermoforming and stretch blow molding materials. And then supporting all of our processing, we have an extensive suite of material characterization techniques, including mechanical, chemical, rheological, and thermal testing. So that's who we are and what we do. But why are we interested in recycling plastics? Well, it's almost every day that we see images like these in the news showing how our waste can impact on the environment around us. And while we can all agree that reducing any waste is a good thing, plastics in particular have got everyone's attention. Rotacycle was a name given to our Innovate UK funded research project, and this was investigating the use of hard to recycle plastics in rotomolded applications. And the basic plan was for impact recycling based in Newcastle upon Tyne to recover post-consumer plastic and supply blends of these to ourselves at the University in Belfast to grind and rotomold. Impact Solutions would then carry out testing of the materials used and also check mechanical properties of the rotomold parts. And then Harlequin would finally mold a full-scale product, which would be tested also. Harlequin were the lead industrial company. They're based in Moira in Northern Ireland, and as you can see, they manufacture a range of products, which include fuel storage tanks, diesel tanks, wastewater treatment systems, pump stations, and rainwater harvesting systems. Impact Solutions are a company of independent plastic experts who offer a range of services, including testing of plastic products to certified standards. They've also gained a wealth of experience in recent years in testing of recycled blends, so they were obviously a perfect fit for this project. Impact Recycling recover waste plastic from a variety of sources, and they have developed their own patented baffled oscillation separation system, or BOSS. And this technology allows them to produce blends of either polyethylene or polypropylene, which are up to 98% pure, with the other 2% being polypropylene or polyethylene also. So what are post-consumer plastics? Well, they can come from a variety of sources, including council recycling centres, where we tend to bring bulkier items such as garden furniture, toys and buckets, as you can see here, but also smaller items that we all recycle in our house and are collected by councils weekly or fortnightly in our wheelie bins. And then there are other sources, such as post-industrial waste, for example, from construction sites. This material is then sorted, shredded, washed, chipped, and produces the flake that you can see. So the first question that we asked ourselves as a group was, can we grind the flake directly and proceed to rotomold the recycled material? So the flake that you're looking at on the right-hand side here is about 12 millimeters long on average, so about the same size as the buttons on the keyboard sitting in front of you. This is our Wedco pilot plant grinding machine, and we started with this 12 mil flake. But as you can see, the material started to stick to itself, which would have led to a meltdown. We can also see flake in the ground powder. We then decided to chip the flake to a smaller size, to 5 millimeters, and see if this made a difference. But unfortunately got the same result in the grinding head and also resulting in flake in the powder again. So we decided then to try cryogenic grinding to see if that would improve the powder quality. Flake was soaked in liquid nitrogen at minus 195 degrees centigrade for 10 minutes to make the plastic brittle, and then fed manually into the grinding head. When we opened the head, we could see that there was no sticking. However, the powder still contained large pieces of flake. So it would appear that the flake is passing sideways through the gap in the grinding plates. And we knew then that we needed to move to compounding to produce pellets. We chipped the flake to less than 5 millimeters in order to be able to be easily fed into our extruder. We used a twin screw extruder to give us optimum mixing, and we tried to keep the temperature as low as was practical, in this case about 185 degrees at the die. We also knew that most recycled materials that we were using were coming from parts which had not been rotomolded and therefore did not contain antioxidant. And we knew that this was needed for the process. So we took the opportunity to add this at this stage. We also looked at a range of different mesh size filters to explore whether we could remove impurities from the molten plastic and improve the properties. When we passed the pellets into the grinder, you can see that they still were starting to agglomerate, both in the grinding head, but also in the exit tube from the grinder itself. Oh, excuse me. And when we moved to cryogenic grinding, we could see that we got a clean grinding head with a consistent homogeneous powder. A range of recyclates were then produced by impact recycling, and we used parallel rheometry to measure the viscosity of each blend at a shear rate close to zero, which is similar to the rotation molding process. You can see that some of the blends at the top had a much higher viscosity than the four at the bottom. And in rotational molding, that's important because it can be a problem, and as it's more difficult to get rid of the bubbles in the melt in order for them to dissolve, and therefore this affects the mechanical properties of the part. So this technique allowed us to really hone in on particular blends of recyclate to rotomold. This is our Ferry rotational molding lab at Queen's University, and you can see our carousel machine with a straight arm in the foreground, and in the background our drop arm. We used a cube test mold attached to the drop arm on our machine. The mold is about 300 millimeters long on each side, and this produces a nice flat sided part from which we can easily cut mechanical test specimens such as impact, tensile, and flexural. We also used a Rotopack temperature logger to monitor in real time the air temperature inside the mold. And in case you haven't seen one before, this is the kind of trace that we get. We use this type of system on every single part that we mold at Queen's, and it allows us to see when the material is melted, when it has solidified, and we can use the peak temperature as a reference to ensure that we have the same heat history for each part that we produce. And therefore, we can be confident that when we mold different materials and we compare their mechanical properties, we know that we're comparing materials, knowing that the processing has been the same. For the 100% recyclate moldings, we found the outside surface to be relatively smooth, with the inside surface somewhat more rough by comparison. So we decided to add in a second layer of polyethylene to smooth out the inside surface. And as you can hopefully see in the cross section, the ratio was about 40% recyclate as the outer layer and 60% virgin polyethylene as the inner layer. We hope that this would bolster the impact strength of the overall molding. We measured the impact properties using a machine like this, where the dart was held at a height of 1 meter before being dropped on the sample, which was housed inside this chamber at the bottom. Sample sits on an anvil with a ring clamp to hold it in position. The tip of the striker contains a force transducer, which measures the resistance force of the test specimen as it's being broken. And depending on the thickness of the specimen that we cut from our rotomolded part, we can vary the weight of the striker to ensure the specimen will fully break. When the striker impacts on the specimen, you can see that the test piece bends so that the top or the outer surface is in compression, whereas the bottom surface is in tension. The crack then actually initiates on the bottom or inside surface and almost instantaneously propagates to the top surface, at which point the striker then passes through to fully break the sample. The machine then calculates the area under the force displacement graph that you can see and gives a readout of peak energy, which is the area under the graph up until the test piece cracks, and also the total energy required to break the test piece, which is the total area under the graph. We then divide the peak and total energy by the thickness of the test piece to give us impact strength in joules per millimeter, which you can see in this graph. So we've got impact strength on the left-hand side, and we've got 5 different materials. We've got the peak and total impact strength for each material. So the first one, so we start on the left-hand side. The first grade is a virgin polyethylene rotomolding grade of PE. We then have a post-production rotomolded scrap, which has been reground and remolded. And then we have 3 materials which all contain post-consumer recyclate in a 2-layer structure, again with a 40% recyclate on the outside and an inner layer of 60% virgin polyethylene. And you can see that we've tried a couple of different compatibilizers. So if we look at the trend from virgin PE through reground and remolded PE to post-consumer recyclate, we see that the properties drop off. And in fact, if we use the wrong compatibilizer, we can see that the properties drop off even further. But if we use the correct compatibilizer, we can see that the properties are improved slightly. And when we compare what we consider as the baseline, which is the post-production rotomolded scrap, which has been reground and we know can be made into parts which are commercially viable, and we compare that against the best post-consumer recyclate we had, we see that the total impact strength drops from about 11 to 9, so a little bit of a drop. And the peak impact strength goes from 7 to 6, slightly smaller drop there. So we see this as very encouraging that we can produce a part which could be rotationally molded out of post-consumer recyclate, perhaps optimize somewhat further, perhaps changing the amount of compatibilizer, perhaps changing the compatibilizer itself, and this looks very positive. The second project I want to highlight is the Accept Transitions project, funded by the Engineering and Physical Sciences Research Council. This project is still ongoing, and it's a collaboration by academics within Queen's University from the School of Architecture, Psychology, Chemical and Mechanical Engineering, as well as a number of industrial partners. And the brief is to look at consumer behavior and perceptions around plastic waste. For example, what makes us want to recycle? What incentivizes the consumer? What value do we place on recycled products? And are they thought of as attractive? So an interlocking building block was chosen as a demonstrator product, and rotational molding was the obvious method of manufacture, which is where we come in. This is one of those interlocking blocks which we have rotomolded. And the idea is that when several of these are built together, they cast shadows across the wall, and hence the name shadow block. So this was produced using 50% virgin polyethylene powder, along with 50% chipped flake to give this unique recycled look. We manufactured many other blocks to build the wall that you can see here. And one of these is actually made from 100% recyclate, which is this matte gray one towards the bottom. However, the feedback from the psychologists and architects is that they very much prefer the look of this one with the recycled flake, as it screams recycled content at them. And they believe consumers will then have more of a connection to it and will therefore place more value on it also. In August, Alex Sharma, the current business secretary, visited the university to discuss research both on sustainable materials and energy, and we were able to showcase some of the work that we were doing as part of these two projects. The second mold design that the architects in our team created is this classic cupid shape, which is also an interlocking block about 0.5 meter tall and about the same wide. We've just recently received the mold from Persico, but we're looking forward to molding blocks shortly in order to demonstrate that what can be achieved with recyclate, and also try and engage further the construction sector. This mold is made from CNC machined aluminium and really is of a very high quality indeed. And here you can see it sitting on the drop arm of our Ferry Rotaspeed machine, literally just waiting to be molded. Thank you very much for your kind attention. And if you have any questions, I'll be happy to take those now.
Thanks, Paul. I believe there's one question, so it's over to you, Paul.
Yeah, so the question is, in fact, there's two questions that have come in now. So what temperature were impact samples preconditioned at?
So the impact test specimens were at room temperature. So the results that you're looking at are all room temperature rolling. So they're about 22 degrees.
And the second question is, what was the compatibilizer? And do you have experience with foaming PCR?
So to answer the first part, the compatibilizer I've labeled, as you probably have noticed, as compatibilizer 1 and 2. So the project finished just over a month ago, and when one of these projects finished, we need to discuss with the partners exactly what we disclose and how much we can and show to the industry. So at the moment, that those discussions are still, the detail of those are just being fine-tuned, and I didn't want to upset anyone. And so we'll come back to the compatibilizer in the future, and we'll certainly be presenting these results further in technical articles, and hopefully we can disclose what that is at that point. On the post-consumer recycling and foaming, yes, we did try to foam the material, but we actually found with the standard foaming agents that we were using, which were OBSH types, they have degradation temperatures around about 160 degrees centigrade, where they give off the gas and blow, that actually we didn't see very much foaming. And we suspect that we either have some small impurities in the recyclate, which are activating the foaming agent prematurely and therefore gassing off before the solid lays up and becomes a molten liquid, which we need it to be in order to create that viscous liquid foam. Or we think that the polypropylene, the small polypropylene content in the material has unduly stopped the foaming agent from foaming the overall material correctly. So we think there's still a huge body of work to do to look at in terms of both foaming agents and in optimizing that process. But it's something that we fervently want to pursue and look at.
So there's two more questions that have come in, so we'll try and get those in. Which was the polymer distribution in PCR mix? Mainly PE and PP, or also other contaminations? So
we looked at, so I mentioned that the impact recycling can produce up to an 98% pure material, and towards the latter part of the project, that's what we were using. However, in the earlier part of the project, that system hadn't been perhaps just quite as refined at that stage, and also it's an extra step in the process to purify the material more and more to get it to that. So we were looking at the low-hanging fruit, and we did use polyethylenes, which contain maybe 20% recyclate, which is probably more typical of what you would get from most recyclers of polymers. But in the latter half of the project, we looked at the more pure materials, which is unique to impact recycling.
Thank you so much. And our final question is, how can you be sure the product won't fail in sunlight? Did you include any UV system?
So we did not use any UV stabilizers in the parts that we produced. And the reason for that was that our project was fairly short term. And whilst we know that that's important, we were literally checking the results of something, and then proceeding with our plan. And that was looking at different purities of recyclate, different compatibilizers, and we didn't have the time to commit to years of accelerated weathering to check the long-term properties. But we realize, of course, that is something which needs to be looked at.
Paul, thank you so much. And Phil, that was the last question that we received.
Thanks,
Great,
Paul.
thank you very much, Paul.
Thanks, Phil.
No, you're welcome. And that concludes this British Plastics Federation online seminar. I would like to take this opportunity to thank all the speakers from today for their presentations, and to thank you all for listening and for your questions and being very patient. After this online seminar ends, a short feedback form will pop up on your screen. If you have 2 minutes, then please fill this form in. It would be greatly appreciated to give your views so that we can make the most of the next webinar, even better than this one, which is obviously a trial. It's the first one we've done. And with that, thank you all and goodbye.